Hello guys, welcome to my channel. This is the 28th tutorial in this course, and in this tutorial we are going to talk about bitwise operations in C. Now, some of you watching this video won't be knowing what bitwise operations are, and obviously would not be knowing why we have to understand bitwise operations and how we have to perform them using a programming language, which is absolutely fine because most programmers do not know it. And the reason for that is that you don't have to know, right? Because you only work with integers and characters and other fancy data types, but you're never really bothered about what happens at the bit level. So if you guys do not have an idea about what binary representation of decimal numbers is, then I actually thought about discussing that in this tutorial, which would have been fine because it's not beyond the scope of this course. But then I couldn't figure out a way of doing that. So instead, I would ask you guys to search for it on Wikipedia, how decimal numbers are converted to binary. And if you guys don't know that already, then you can read that article. There's a beautiful article on it, and you can read that article and know it. And there's another article that I would recommend you guys to read, and this is Bitwise Operations in C. So search for Bitwise Operations in C on Google and follow the Wikipedia link. And you would see that there are 6 bitwise operations that C allows us to perform using 6 different operators, and there are 6. And we're going to check all of them out in this course, but I'm just not going to discuss in too much detail what these operations actually are and what kind of significance these operations hold. So anyway, that's the reading. I'm not going to scroll through the entire article for you guys, and there's some implementations down there in the article. You don't have to be concerned about those implementations. Just go through the matter and try to understand what these operations actually are and how you can perform them on paper if you have to, right? So in this tutorial, what we're going to do is I'm going to discuss 3 bitwise operators. In the next one, I'm going to discuss the other 3. And I have a notepad file which I haven't saved, and then I have a file that I have saved using code blocks. It's called bitwise_part1.c. On line 1 I have my header file. On line 2 I have declared the main function. My curly braces are there so I can type in my code. Now there's another tutorial on YouTube in which someone has discussed bitwise operations, and the guy has mentioned that you need to include another header file, the stdlib standard library.h header file. But I don't think that's necessary because I have performed bitwise operations without using that header file, and I've always been able to do my work, and code blocks or any other IDE for that matter has never thrown an error at me. So you don't have to put in that header file, and stdio.h, if you have that one, then you're good to go. So I'm just going to take 2 numbers. Firstly, bitwise operations obviously happen at bit level. So each number in memory is stored in the form of a binary string. If you guys don't know what a binary string is, then you can represent all decimal numbers in terms of ones and zeros, right? So whether it's 9 or 47 or 515, you can represent each number in terms of ones and zeros, and that is how the computer stores these numbers, and that's how the computer manages everything, in fact. So because the computer just understands high and low, right? So presence of voltage or absence of voltage. So that's I'll probably discuss that sometime else. But for the time being, I'm just going to take 2 numbers, and in the program I'm going to store these numbers in 2 different variables. The first one I'm going to call A, the second one I'm going to call B. So let me assume that A has the value 59, right? And B has the value 32. But let me take a greater value. Let me take 42, right? And I'm going to use a tool to convert these numbers to the respective binary representations, and the way I'm going to do that is by using Google. So I have opened my browser, and I'm going to search for decimal to binary converter, right? So why isn't the search results showing up? Yeah, there they are. And I'm going to follow the second link on screen, which is to the URL binaryhexconverter.com. So I'm going to click on the link, and you would see a very simple interface. There are 2 text boxes. In the first text box, you type in your decimal value, and the second text box, you would get your binary value if you click on the convert button. So the values that I have taken in this tutorial are 59 and 42. So I'll first type in 59 and get the binary value, which is this. I'll copy that and I'll put it over here. And the next value is 42. And I'll type in 42 in this text box now. I'll click on convert and I get this binary value. I'll again copy it and put it in my notepad file. So, well, I don't have to save it. So now we're gonna check out the first bitwise operation, and that's the bitwise AND operation. And I'll just tell you guys in brief what bitwise AND means. When you perform bitwise AND operation on 2 bits, then the resultant bit is 1 only if and only if the bits on which you're performing the bitwise AND operation, both the bits are 1, right? So if you would perform the bitwise AND operation on these strings, then just a moment, the first set of bits that we have, 1 and 1, would result to 1. The second set that we have 1 for the first string and we have 0 for the second string, so the result is going to be 0. The next value is again going to be 1 because the bits on which we are performing the operation are both 1. For the fourth set, the value is going to be 0 because both bits are 0. For the fifth set, the value is going to be 1 because both bits are 1. For the last set, the value is going to be 0 because one is 1 but the other is 0. So I'm going to copy this value and I'm going to go to this converter thing again, and I'll scroll down and I'll see that there is another tool that this website offers, and that is binary to decimal converter. So we can also convert binary strings to the corresponding decimal values. I'm going to make use of this tool. I'll type in my binary code here, or rather I would paste the value and then click on convert, and I will see that the result is 42. So the resultant string is the same as the string B, and I didn't notice that, that's why I use a tool. But anyway, we're going to use a tool for doing other things in this tutorial. And now we're going to see how C generates this for us. So I'm going to declare 2 integers. As I said, the first one I'm going to call A, and I'll give it the value 59. And the next one I'm going to call B, and I'll give it the value 42, right? And then I'm going to use printf to display the result of the bitwise AND operation on these 2 numbers. So the result of bitwise AND operation on the, why do I have to type in so much? I'll just put in a colon and the %d format specifier, and after the second double quotation mark I'll put in a comma, and then I'll type in the first variable name, which is A, and then I'll type in the ampersand symbol, but just once. And you remember, for the logical AND operation we have to type in the ampersand symbol twice, but for the bitwise AND operation we have to just type it once. So you type in A, the ampersand symbol, and then you type B, and then you put your semicolon after the closing parentheses, save the file, click on build and run, and you see that the result of the bitwise AND operation is 42. So C generates it for you. So the next operation that we're going to check out is the bitwise OR operation, and I'll bring up my text file again and I'll remove this string, and we'll understand how the bitwise OR operation is performed. So the bitwise OR operation results into 1 if either of the bits is 1, right? So in the first case we have 1 and 1, so the result is going to be 1. In the second case it's 1 and 0, and since one of the bits is 1, the result is going to be 1. For the third case, again it's going to be 1. For the fourth case, since both bits are 0, the result is going to be 0. For the fifth set, the result is going to be 1 because both bits are 1, and for the final set, the result is again going to be 1 because one of the bits is 1. So I'll copy this string now, right? And well, as you guys can see that this string is similar to the string A, right? It's not similar, it's identical. In fact, 111, 011, and 111, 011. So we know that the result of the bitwise OR operation is 59. So I would go to my code blocks file again, and the only changes that I would have to make to this file are, I would have to change the word AND to OR here, and I would have to remove the ampersand symbol here and replace it with the pipe symbol. And again, you guys, if you've been following along the tutorials in this course, then For logical OR operation, you need two pipe symbols, but for for bitwise OR, you just need one. Save the file and click on build and run, and you will see that the result of the bitwise OR operation is 59 as we expected. The last bitwise operation that we are going to check out in this course is the exclusive OR bitwise operation. And let's again visit our text file and understand how the bitwise exclusive OR operation works. So the exclusive OR results into 1 if the bits are different, and if the bits are same, then the result is 0. So in the first case, in the first set, we have to perform the operation on 1 and 1, so the result is going to be 0. For the next set, since the bits are different, we'll have 1. For the next set, we'll have 0. For the next set, again we'll have 0. For the next set, again we'll have 0 because the bits are same. And for the final set, we'll have 1 because the bits are different. So I'll copy this string and I'll go to this tool. I'll put in my binary value. I'll click on convert. I will see that the result is 17. So now let's see if C generates the same result for us. And the symbol for the bitwise exclusive OR operation is the cap operator. And if you guys don't know where to find it, then you have to shift up on key 6, right? So this is what I mean. This is what you have to get. If it looks familiar, perfect. And I'll save the file. I'll click on build and run. And there you go. You see that the result of the bitwise exclusive OR or XOR operation is 17. So that's it for now. I don't want to extend this tutorial by saying things that are not really necessary. I have a habit of doing that, by the way. I'll discuss the remaining 3 bitwise operations in the next tutorial. And thank you so much for watching this one. Read that article on Wikipedia if you have any doubts, or you can obviously put in your comments and I'll try to reply to as many as I can. And thank you for watching this. And please subscribe to my channel in case you haven't already. See you soon.